Okay, hello everyone. This is our first video of the calculus series. So here we are going to learn what a derivative is, and we are mainly going to discuss about introduction to derivatives. So at first let's understand what a derivative is. Derivative is just the differentiation of a function with respect to a variable. The variable can either be time in most of the cases, distance, or if a function is given, then we will differentiate it with respect to x. This is derivative. Okay. A lot of techniques are being used here. So for the representation of derivative, if fx equals to x square is our function, this is our example, then the derivative of fx equals to x square can either be represented by dy by dx or can be represented as f dash x. Even in some cases it is represented with y dash also. Okay, so this is a basic overview of derivative. Now we are trying to we will understand how to differentiate it in the mathematics. Okay, so let me rub this out. Let me push this further down. Rub this out. You can just grab your pen and pencil so that you can make better notes with this with the information that I am providing you about derivatives. The first method to solving derivative is with the use of first principle. So there is a formula for first principle. If to differentiate dy by dx, and if x tends to 0, limit, or instead of x we can write h tends to limit 0, then fx plus h minus fx by h will be our first derivative, where the value of h is small increment in x. So if the value of x is 3, then this is just a small increment, so this can be 3.1, 3.2, and we're trying to differentiate it with the use of first principle. Let's try to solve some of its equations. Okay, suppose equations provide us with a equation y equals to x plus 3, and we are trying to differentiate it out. So this is our fx equals to x plus 3. If you are trying to calculate fx plus h, it will be x plus h plus 3, where h is small increment in x. So the value have just increased. We're just increasing a little value in x, which is h. So if we try to calculate dy by dx, then at that scenario the increment h should tends to limit 0. Let me make it more clear for you. So increment h tends to limit 0, fx plus h minus fx divided by h. Okay. Let me scroll it down. Okay, after this, as we are trying to solve for x plus 3, so it will be h tends to 0. Instead of fx plus h, we can write x plus h plus 3. Instead of fx, we will write minus x minus 3 divided by h. So this, the value of x and x got cancelled out. 3 and 3 also got cancelled out. Okay, so h tends to limit 0, h divided by h. H and h again got cancelled out, and we are going to get the derivative as 1. So this is our answer. So we are solving this with the first principle. First principle will be used by taking a small increment on x and small increment on y. We are calculating approximate values with this. So now we are going to calculate the exact value, okay, or the accurate value by using certain formulas for derivatives. Let's do that. Let me rub this out. I guess you have copied this. If you have not copied it, you can just pause the video and copy it. So here we are going to discuss formulas for derivation. Okay, suppose similar case, if I get y equals to x to the power n, as we have discussed about in the first principle. So if I'm trying to differentiate this out, then if I do dy by dx with respect to x, and then my answer should be nx n minus 1. This is our first formula. Okay, let's check this out with y equals to x cube plus 3x square plus 2. Let's take a complicated example. You just focus on this question. Okay, it's not that hard to understand. If you just put a little bit of focus, it's easier to understand. Okay, differentiating with respect to x, so dy by dx. So as we know, the constants cannot be differentiated, but the variables can be differentiated. So this will be dx cube by upon dx plus 3 taken as constant, dx square upon dx, then plus d2 upon dx. Okay, in this question you need to also understand that if there is a constant given, then at that scenario the derivative will be 0. Here instead of n there is 3, so it will be 3x to the power 3 minus 1 plus 3 dot 2, as 2 will be our n here, x to the power 2 minus 1 plus 0. After solving it further, we are going to get 3x square plus 6x as our answer by differentiating it with respect to x. I guess you have understood our first formula, which will be nx n minus 1. Okay, let's get down. Let's get into another formula now. Okay, now we are discussing formula number 2, which is power rule. Equation gives y equals to x square plus 3 whole square. So there are two cases for solving this question. Either we put the formula, but if the power is higher, suppose there's power 4, power 5, power 6, then at that scenario this might not work. So here in this question we are going to apply a rule that is called power rule. Okay, so for applying power rule, there are certain conditions. The given variable should have a power. So let's try to solve this. Okay, let's try to differentiate it with respect to x. So in this scenario, dy by dx equals to dx square plus 3 whole square. As the power is assigned, this variable will be differentiated at first with respect to x square plus 3, as there is the involvement of power. So we will write dx square plus 3. So the given value in power, x square plus 3 whole square, will be differentiated at first with respect to dx square plus 3. After that, dx square plus 3 will be differentiated with respect to dx. So in this way the power rule works. So at first, this whole variables